Hi everybody, I am going to discuss about the topic now on the object oriented system development and UML. This is a topic related to the software engineering. In the software engineering, we develop the applications or the client requirement based on different methodologies. The primary methodology or the traditional methodology we follow is the procedural method, where we consider everything into the normal consideration and develop the application for the client requirement. The second methodology we follow is the object-oriented system development, where we consider the entire application in the form of objects and the related classes. So when we consider the objects and classes, we need to go for a particular method. We call it as a UML. It is a unified modeling language. The unified modeling language is providing a platform to implement the software engineering life cycle phases in the automated environment. So we see the agenda for today's discussion. Now we discuss about the UML, what is the unified modeling language, and what are the tools that are available, the different unified modeling language diagrams. The different diagrams we usually draw for the representation of the application procedure. By default, we deploy the data flow diagram or ER diagrams. Similarly, the UML diagrams also we are deploying, and the different case tools. CASE stands for the computer aided software engineering. In computer aided software engineering, we implement the software development lifecycle phases in the automated environment. Usually we do the manual procedures for the problem analysis, problem design and implementation. All these things are automated. Before this particular UML concept come into the picture, we were doing everything manual. We are doing the analysis manually, we do the design manually, and then convert it into the computer application environment. There we are doing the implementation. The problem we get is, whenever we do the manual analysis and do the automated design and implementation, there is a gap between analysis and design. The gap causes a lot of differences and the damage to the application also. So to reduce the gap between the analysis and design as well as the implementation, we are going for the case tool. So case tool is reducing the gap between the design and the implementation. If you see the unified modeling language, it is a standard language for specifying, visualizing, constructing and documenting the artifacts of the software systems. Artifacts are the main important role that is played by the individual objects in the organization. Here, if you see the artifacts of the software, we have the hardware, the software platform, the language in which we are developing the application, the user required interfaces. All these things are comes under the artifacts. The UML was created by the Object Management Group, OMG, in the 1997. There they started using the UML. UML is not only the diagrams, these diagrams are having the code behind. The code that is validating the diagram which you are drawing. Suppose if you draw the diagram using the paintbrush or the MS Word, there is no validation to the diagram. The diagram is simply an image. So to have the validation, and whenever we make the changes in the procedure of the application development, automatically the diagram should be modified. The changes are to be automatically implemented in the system. That is done using the UML. Using the UML, we can draw the 9 types of diagrams. These 9 diagrams are defining the entire application environment right from the requirement collection till the implementation. The diagrams we use are a dynamic diagram, which is called the use case diagram, and the second one is the behavior diagrams, which are called the dynamic diagrams. These dynamic diagrams are giving the business access or business flow. We call it as business engineering. The business engineering flow or the procedures are implemented in the dynamic diagrams. We have the interaction diagrams. There are 2 diagrams we have. One is the sequence diagram, another one is the collaboration diagram. These 2 diagrams are defining the interaction procedure. Then we have the activity diagram, state chart diagram and the object diagram. And the static diagram we are also using. The static diagram is the class diagram. The class diagram is coming to the design environment, where the classes that we are identifying from the object behavior are represented, and the class relationships are converted into the platform as the implementation. And in the implementation diagram, we have got the component diagram as well as the deployment diagram. These are the 9 diagrams we can draw using the UML. Apart from these diagrams, we can also draw the data flow diagram, entity relationship diagram. And these diagrams, if we draw directly without using a tool, there is no meaning. It is understood by the diagram drawing person only. To make the diagram understandable by the developer, to improve the the understandability between the diagram drawing person called the analyst and the application developer called the programmer, we need to have the automated tool. The automated tool we are using is the UML, we call it as. But there are many tools available which are working from the requirement analysis till the implementation. So in this scenario, we have got different tools. These are the tools that are helping us to automate our life cycle phases. The life cycle phages can be automated using the star UML. These are open source UML tools we have. Open source is a tool that is provided with the code, so that we can modify according to our requirement. Customization can be possible in the open source. In that we have the star UML and the umbrella as well as the Andro MDA. Andro MDA is also called as Andromeda, and it is a model driven by architecture. And the BOUML is developed for the Bruno pages. This is the organization developed the BOUML. And the Argo UML is also another open source which can be directly used by the developers. And commercial case tools are also available. The commercial case tools are paid. You need to pay for that and install in your organization. And then you have got the IBM's rational rows as well as the Microsoft Visio. And using Microsoft Visio we can develop the diagrams, but these diagrams are not validated. If you use the rational rows, IBM rational rows, it has got the validation. The validation decides is there any discrepancy or the ambiguity in the diagram in the relationships. Sometimes we give the wrong relationship between the entities, that is detected by the software tool. If we have such a tool which can detect the errors, that helps us a lot in making the diagram correct. And among all these tools, any tool we can adopt for the purpose of the application deployment. We have got different advantages using the case tools. The basic advantage is it is a universal symbol. The symbols that we use in the UML are the universal, which are identified or understood by anyone in the world, so that the diagrams are accessible or acceptable by every organization. When you go for modifying any application in future, the diagram is helping them. So they can understand the diagram easily, and the diagram can be modified by the new person who is going to update the software. And effective documentation feature is also another one we have. Every software tool, a case tool, is having the documentation. Means the developer should give the labels to every symbol in the diagram. They cannot leave the symbol without any label, and they can also add the notes. Anchor notes can be given. So the anchor notes are giving the description about the symbol and the relationship, so that all these things comes under the documentation. This feature is made the software tool enable in the software development environment, because the application developer need the work they have done. That will be automatically documented by the system using the case tool. There is the documentation feature available. And the more communicative, because the diagram is 10 times communicative than the verbal or the descriptive. That is the reason these diagrams are having the more popularity to express our development procedure. There is another advantage, we have the forward and reverse engineering procedures. Forward engineering is the application development from the analysis, design and implementation. This is the regular flow. So if you want to go for the reverse engineering, it is from implementation to design. So instead of going for design to implementation, we can come from the implementation to design. Here the design is the diagrams that we are drawing. For example, in the UML we have got the class diagram. Class diagram is the design. We are designing the classes, and within the classes we are having the methods and the attributes. as well as their relationships. So when we establish the diagram can be converted into the implementation. While implementation, we need to choose a platform, whether you want to implement in the Oracle environment, you want to implement in the JDK or JTEE, whatever the environment you want, you can select, even C++. There are lot of environments can be selected to implement your class diagram. So once you choose that, it will implement. This implementation of the UML diagram is not the complete coding. It is only the base coding for the class construction. Once the classes are constructed, for example Java you are writing, when you write the Java program, if the classes for the application are created, then you can write the remaining part of the program to create the interfaces and using the classes connecting to the backend, all these operations we can do. But whereas in the normal case it is not done. The coding is not done automatically by the tool. So it helps the application developer to minimize the gap between the design and the implementation. There is the forward engineering. And coming back to the reverse engineering is a process where we are doing the implementation to design. The design is done after the implementation. Suppose a person is well versed with the coding, they can complete the coding first and that can be converted into the design. The diagrams can be constructed. That's where we have the conversion to the reverse engineering procedure. Then we have the code generation. I am telling about the code generation only. The basic code generation is converting the class diagram into the selected language classes. That is the code generation. Once the code is generated, the designer need not be with the developer. The application developer can work confidently that there will not be any gap between the design and the implementation. So the code generation is the effective feature with the case tool. And the validations, I am telling you about the diagram. The diagram is not simply drag and drop from the tool. It is also validating whether the relations are proper or legal or not. If there is some illegal relationship, that will be detected by the tool. Such advantage we are having with the tool. I just want to demonstrate a tool which will help us to construct the diagram for the UML. Let us see the star UML. Let us have the demonstration on the case tool called star UML. And this product is helping us to draw the 9 diagrams of the UML as well as the ER diagram. And the ER diagram we will see in this session. After that we will see the remaining diagrams of the UML. These are the diagrams we can draw. A class diagram, package diagram, object diagram, component diagram, composite structure diagram, component diagram, deployment diagram, use case diagram, sequence diagram. From the sequence diagram we can convert into the collaboration diagram, the state chart diagram, activity diagram, profile diagram, ER diagram, flowchart diagram. So let us see the ER diagram. Once we click on the ER diagram, the ER diagram related components are opened here. From here you can drag and drop. Suppose if I select the entity can be kept here. And within the entity we can add as many number of entities you want in the application, you can drag and drop. You can click on the entity and re-click in the editor. That will give us the entities. So within the entity we can add the column. Column can be added. As many number of columns you want, we can simply add in that. So each column is given the properties here. Suppose if we select the column 1 and we can specify what type of data it is, whether it is a varchar or boolean, integer, char. Suppose if it is the integer type, we can select the integer type. And we feel that the particular attribute is the primary key, you can select that one, automatically PK will be added. The second one is the attribute which is of the type, suppose it is the varchar can be taken up. The size can also be specified. Suppose if it is the 30 characters, we can specify. That will also become. Once the entities are constructed, they can be interrelated. So when you go for the relationship, we have the one-to-one relationship, one-to-many relationship and many-to-many relationship. Suppose if we have in this particular entity, we have the 2 attributes. We can add the attributes. and we can also rename the attributes if required. Once these attributes are identified, the first attribute in the second entity can be made it as a primary key, and the second attribute can be of the different data type. We can call it as a character type of the size, suppose 15, and the first one can be an integer type that can have some 10 digits. This way we can make. And once the entities are identified with the proper attributes, then we can establish the relationship. Suppose we have the one-to-many relation. We can drag and drop between these two entities. And here we can mention why this relationship is given. It is for, suppose, data updation. Here is the text. We can drag it and show the relationship. One-to-many relationship is established. And if I want to give the description of this one, this particular entity 1, we have the description here. So at the bottom, you will have the description. Anything that you type, suppose if it is a entity for student data storage, this is the text I have given, and this text will carry as a document for the diagram. When you create the complete diagram of documentation for the entire project of all the ER diagrams and the UML diagrams, it will prepare a booklet with all this description. It must be given properly. The description of the entity, attribute description, attribute specification, the constraints. When everything is given, it is the complete design. And when you select the option for the code conversion, there will be an option we will have the model tool will have the we will have an option to convert the diagram into the coding. So here it will apply the create command, create table followed by the what is the name you give entity, followed by the attribute name, data type and the constraint. Everything is converted automatically by the tool, so that the application developer need not worry about the discrepancy between the design and the implementation. This type of advantage we are having with the case tools. The next class, let us see the UML diagrams, 9 diagrams, how we can draw and how we can convert them into the coding. Thank you very much.